Hello Devices2, this is Professor Late and I will be going over Lab 2. This video will cover the first part. First thing we need to do is make sure we have our lab sheets so we can follow along. Then we'll make sure that we have our Heathkit trainer and all the parts that we need. Once you plug in your electronic design experimenter, make sure that the unit is turned off. Step 2 says we're going to construct the circuit shown in figure 1. Connect from our positive into our top bus. Connect from our ground into our bottom bus. Next, we're going to build the rest of the circuit. One part at a time. You can follow along at home. Our 220 ohm resistor that connects into the anode side of our SCR. If you're looking at the SCR and you're looking at the flat side, the leads go anode, gate, cathode. Connecting our cathode side to ground. Connecting from our gate through our 1K ohm resistor to ground. Connecting from our gate through a 4.7 kilo ohm resistor into our variable resistor. Connecting from our positive DC into our variable resistor. Connecting from our variable resistor to ground. We're going to turn the positive voltage control fully counterclockwise and the 1K ohm potentiometer, also known as a variable resistor, fully counterclockwise. Turn on the experimenter and then adjust the positive voltage control until positive 10 volts is applied to the potentiometer. So I'm turning up the power until I read 10 volts on the multimeter. Now we're going to start filling out figure 3. The voltmeter is connected to measure the SCR's anode-cathode voltage, designated as VF. Record your voltage measurement in volts in the appropriate space in the off column in the table provided in figure 3. Your recorded value represents the forward voltage across the SCR when it is turned off. Step 5. Measure the voltage drop across R4. Record this voltage VR4 in the appropriate space in the off column of the table provided in figure 3. Your recorded value represents the voltage across R4 when the SCR is off. Step 6. Use the voltage drop across R4 and the resistance of R4 to calculate the current through R4 using Ohm's law. Your calculated value of current represents the forward current IF flowing through the SCR when it is turned off. Record this IF value in milliamperes in the space provided in the off column of the table shown in figure 3. Now, our result ended up being at 0 volts, so you can go ahead and determine that the forward current going through the SCR is 0 amps. Step 7. Connect your voltmeter across the SCR again. Observe its forward voltage as you turn the potentiometer R1 slowly clockwise. This will cause the gate current to increase. Continue to turn R1 until you note a change in VF. Stop turning R1 and record the new VF value in the space provided in the on column of the table of figure 3. Your recorded value represents the forward voltage across the SCR when it is turned on. So I'm going to slowly turn this potentiometer, watching the multimeter. At a given point, we dropped from 9 volts or so to 800 millivolts. So this is what you'll put into the table of figure 3 for your on VF. Step 8. Measure the voltage dropped across R4 and record your measured voltage in the space provided in the on column in the table of figure 3. Your recorded value represents the voltage across R4 when the SCR is turned on. Step 9. Use the voltage drop across R4, which we have 9.1 volts, obtained in step 8, and the resistance of R4, which is 220 ohms, to calculate the current through R4 using Ohm's law. Your calculated value represents the forward current, IF, flowing through the SCR when it is turned on. Record the value of IF in milliamperes in the space provided in the on column of the table shown in figure 3. Step 10. Turn R1 fully counterclockwise to reduce the IG to 0. Now measure the voltage drop across R4. You can see we still have 9.1 volts. Measure the VF, which you can see we still have 811 millivolts. Use these voltage readings to determine if the SCR is still on or if the device has been turned off. Step 11. With the electronic experimenter turned on, disconnect one end of R4, then immediately install the resistor lead back into its original position. This will momentarily reduce IF to 0. Measure the VF and the voltage drop across R4 again. So we have a VF measurement of 9.947 volts DC. And we have an R4 voltage reading of 0. Determine if the SCR is on or off, according to your measurements. Turn off the experimenter. In place of the R4, install a lamp. This lamp will provide a visual indication of the SCR's operating state. It will turn on when the SCR switches its state to off. Ensure that the potentiometer is fully counterclockwise. Now turn on the experimenter and observe the lamp's condition. Is it on or off? Turn the potentiometer R1 clockwise until the lamp changes state and note its condition. Indicate the lamp's condition. Step 14. Turn the potentiometer R1 fully clockwise, and again note the condition of the lamp. Turn off the experimenter. Wait at least 10 seconds and then turn it on again. Note the condition of the lamp. Is the lamp on or off? This concludes part 1 of Lab 2. Please read the discussion following step 16, and I'll see you again for part 2.